these guys a while back. Got 3 of them from Amazon for like 10 bucks. As far as the specific intended usage of them, the legitimacy, I don't really know, but they seem to be pretty legit. From fully dead, these things will suck 4 or 5 amps and charge fairly quickly. You don't have to charge them at that rate. Bump it down to closer to an amp or 2. It's actually going to take a little while to charge. But you throw it on, 4 or 5 amps, this thing will charge right up. Good thing about these, obviously, is the low internal resistance. Got this guy hooked up, same Supercap. It's the voltage on it right now, using a flashlight. This is the drain. It's pretty slow, but as far as these Supercap Joule thieves go, for 100 farad cap, that's probably what you should expect from light like this, where you're probably pulling a couple milliamps, maybe a few tops. Most videos I've seen of these, there's been some that had some really cool legit setups run from higher voltage supercaps. These Joule thief setups, I've heard anywhere from you get a good hour to 24 hours or all type of stuff. But from my experience, if you want something like this where if you shine directly at the camera it looks pretty bright, but in reality it's only a couple milliamp draw, then yeah, you have a pretty usable light. I mean, this thing will last for many hours. Now I could cut this off now. Pretty much have to use this. I would say a more realistic kind of light, let's cut this up, is going to be what you'd actually want in a bright flashlight. It's going to be something closer to me pumping this to about there. And now you can see the draw has increased. Now we're not getting anywhere near the runtime that we would have, but the light has now become, in my opinion, much more significant. It's actually useful now. This is something I can be proud of and say, okay, that's a capacitor flashlight. It's using this LED, I can navigate with it, blah blah blah. But now we're more realistically pulling, I would say closer to 50 milliamps or more, somewhere in that range. We're no longer in the super low draw territory to get realistic usable light. And as far as how long this is going to last, you can see we're not pushing hours anymore. It's probably going to be closer to maybe an hour tops. And as it goes through that process, it'll drain down. Now, the good thing about this guy is it'll still give usable light down below 0.5 volt. But as far as the whole charge it for 30 seconds, let it run down all day or several hours, that's where you have to sort of have to find an in between. Obviously, really all depends on how you want to go. I've got a bunch of different LEDs that I would try here, but mind you, this is a 100 farad cap, and that's how big it is. And this is about what I've noticed to be what I can get from a fairly efficient Joule thief setup. So yeah, I'd say something about that right there. You basically just build a setup where I guess you could have different settings. This right here could, if I wanted to, be like my medium setting. If I really wanted to, I could bump that back up to where it was at a high setting, and at the very least you could probably get 30 minutes or so of that. Or more realistically, depending on the Joule thief, maybe like 5 minutes. But that in itself isn't too bad. So whereas if that's only an emergency like turbo, and most of the time you're running it from something like this or even lower, because if I crank it all the way down, then light output hasn't dropped all that much, and still getting pretty good light. You know, like whereas this guy, I just like the idea of this one essentially going to run for so long because it's as a low power oscillator. This one's really great, but when I start to try to get more light out of it, something like this, not too bad. Once I crank something like that out of it, that's when it's really blowing through that capacitor. If I fine tune a good little spot maybe where it's not quite full output and I'm not draining anything in the transistor, then that right there will give me about a good 30 minutes to an hour or so. But again, you know, this is a 100 farad supercap, and I'm not getting, you know, many hours out of it. It's more realistically closer to 30 minutes or an hour, unless I was to tune it back to a more realistic Joule Thief output light, which might be something closer to this right here. Then you're going to get a whole lot of runtime. But then in itself, I mean, it's not very useful. Trying to drain this one down. It's all the way up unnecessarily, wasting current, but still going. So, see, this one is cut out until I touch it. It's in the low frequency range of RF. So if I maybe time for charging. Alright, got this guy on the power supply, which is just set to 2.4 volts right now. Set voltage on the cap. Gonna cut it on and charge it. And right now it's not pulling a whole lot of amps, but this thing will pull up to 4 amps or more from dead. Put a lot of amps into that thing. Very low internal resistance. So now we're just charging it back up to pretty much where it was before. About 1.5 volts. So go ahead and cut it off there. Alright, this guy's channel 1 yellow. This guy's channel blue 2. And the voltage of each one respectively. This one's going at a pretty decent brightness. The yellow right here. If I cut him down, way down, starts to turn into more of a dirty sign. This guy right here is doing this small blink at the highest resistance, which is going to very slowly drain that. That's what's contained within each pulse. So it swings negative a little bit and shoots up in a little spike, comes back down, and so forth, till it rings out, and that process is over with, and it starts another one further down the line. If I cut that up, it will slowly increase in pulses per blink until it starts to form more defined pulse there. See if I tune it just right. It's real hard to see. I don't have the right potentiometer. I can almost kind of get it. There you go. Here's another potential setup just threw together with a little transformer that seemed to work out pretty well. And this one's got the higher voltage LED board on there. So caps at 2.27. If I crank it up, so you just got a little bit of light. Fairly decent drain on that cap. If I bring it up to about there, where that's pretty good Joule thief light. See, it's blowing through that cap pretty quick. If I try to find a good little spot. So right there, as far as like the high, I'm not going to get too long there. It's cranking easily 50 milliamps or more. So you really gotta bump it back. Something more reasonable like that to get any decent runtime. See, that's what the draws at, or the drains looking at now. So yeah, that's not hours, but that's longer than 5 minutes, looks like. But still, 100 farad, pretty damn big. Alright, this is what I ended up with. A whole lot of variables to consider. You got size, how long you want the light to last, how bright it's going to be, a lot of different things. But I've got so many flashlights that I decided I wanted one that was basically just running from a capacitor, but would run for as long as I could get it to run. And since this is a 100 farad capacitor, the downside there is that means once this thing is fully drained down and I resort to the crank action on here to recharge it back up, that's going to be a good 5 minutes of cranking to get that back up there. And what I did with this one, I just put a blue LED on there through a 220 ohm resistor, and that blue LED does not actually illuminate till this voltage reaches to about 2.4 or so, and it'll get bright at closer to 2.6. So once that light comes on, I can really stop charging it, or I could go ahead and crank it up till it gets fully bright. But that's the voltage on the cap now. And I tried to choose a Joule thief circuit that would work the best for this. Now I know at a lower setting such as this, I can get many hours of light. But whereas with this circuit, once I tried to crank it to real usable light, which is about right there or so, I wasn't getting the runtime that I really wanted. And whereas like with this guy, upon really low power, this little cap in there, it'll blink once it gets to a low voltage. So that's essentially what this does. I have a nice ramping from high to low, and once the cell reaches closer to about a volt or so, the low setting then turns into a very bright blink. So that's cool to me. The way this is, I've got a couple leads on there now still, just so I can see the voltage, and I've got basically just using a pot to turn it up and down. So at the lowest setting, when I cut it on, it's pulling very little from that capacitor, and this amount of light is just barely enough to navigate. I mean, you're reading a map with this or something like that, but you don't want to be outside trying to navigate with that low of a level of light. So to do that, you obviously have to crank it up. Now when I crank this thing all the way up, it pulls a lot of juice. That's because just the voltage that it's at. All the way up closer to about 2 volts, this thing is about perfect. But if I ease that back just a little bit, where I still have the same amount of light and I'm not really wasting anything in the circuit, that's my draw becomes more reasonable. So at this point, I've got a good navigating, usable flashlight. My lead screwed up. It'll actually last quite a while. Now that's a pretty huge cap, but you know, like I say, you've got variables that you have to consider. Now, at one point, I considered running a higher voltage LED load on here, which is very doable. I've got a lot of Joule thieves that can run, you know, 30, 100 volt loads even from a AA. They'll get fairly bright, but realism kicks in there where you're pushing a certain number of milliamps, and this cap is going to blow through that. So you have to find a nice in between, and I reverted back to the good old baby LEDs. Even though I don't like the color, they seem to work pretty good for this application. One seemed to work better than two. Now, whereas I noticed with this particular setup, a 5 volt load was actually really what this thing likes the best. But I didn't like the brightness of my 5 volt load once this thing went down closer to a volt. So just considering all the variables, this was the best way to go for me. Basic Joule thief setup. Now, having said that, I think actually the best way to do this overall is to use a higher voltage capacitor and more or less create a buck circuit for a lower voltage LED, as opposed to create some bootleg boost circuit here with this blocking oscillator setup, which, like I say, worked out okay for me. I had to use a little bit of magnets to tune that core a little bit, that coil, but other than that, worked out pretty good. So something like this, I haven't done a full rundown test of it yet, but I've navigated with it, walked around with it at night. It's pretty good light. So for that run time, that's got to be at least an hour. I'm thinking probably closer to a couple, so that's not bad. So here we are in the dark. Got the torch on, and just kind of give you a little example. So you can see, it's not crazy super bright. It's not competing with your commercial flashlights, but it is putting out enough light for you to navigate with. And with all the lights off in this room, if I was to aim this at the ceiling, I could actually see what's going on. It's not going to be the most pleasing light, but you can see. So yeah, something like this that'll last a couple hours, where you really won't be using it all the time, but it'll be there if you need it. And if you're ever in a jam, if you gotta give it 5 minutes of elbow grease, cool. But the ups and downs there is you might have a light that'll take 30 seconds of cranking, but you're not going to get the same runtime out of it. So would you rather have something that you crank for 5 minutes and lasts a good couple hours and you forget about it, or would you rather have something you need to constantly keep cranking for 30 seconds every few minutes? So really all depends.